So for del of 2t, what we have written is equal to 1 by 2 del of t, 1 by 2 del of t, that we have seen is equal to minus a by 2 to minus a by 2 to a by 2, alpha is equal to a, limit a tending to 0, the corresponding area is equal to 1 by 2, corresponding area is equal to 1 by 2. Then what about the value of del of minus 2t, del of minus 2t, what about the value of del of minus 2t, this is your del of 2t, del of minus 2t is nothing but simply, this is your a by 4, and this is your a by 4. Now del of minus 2t, it is simply minus 2t is equal to 1 and t equal to minus 1 by 2, t equal to minus 1 by 2 only, or the reversal of the signal only. This is your del of 2t, the reversal of the signal only. The signal only becomes a by 4, minus a by 4 become a by 4, and this will become a by 4. This is equal to 1 by a. Corresponding area is equal to 1 by a into 2a by 4. This is equal to 1 by 2. 1 by a into 2a by 4. This is equal to 1 by 2 only. For del of 2t, the area is 1 by 2 only. Del of minus 2t also, the area is equal to 1 by 2 only. So we can write this one also. This one also is equal to 1 by 2 into del of t only. 1 by 2 into del of t only. Since del of t equal to del of minus t, 1 by 2 into del of minus t, and this value is equal to simply 1 by 2 into del of t. 1 by 2 into del of t. Since this del of minus t is equal to, what is del of minus t? This del of t is equal to del of t equal to addition t equal to 0 only. So minus t equal to 1, t equal to minus 1. We minus 1 multiply with 0. We have del of minus t also, t equal to 0 only. This is so del of minus t is equal to del of t only. So we can conclude. Del of a t is equal to, we can conclude del of a t equal to 1 by mod a del of t, 1 by mod a del of t. What about the value of del of a t plus b? What about the value of del of a t plus b? Del of a t plus b, this is a combination of shifting followed by the scaling. So first of all, we have to write the shifting. The corresponding del of t plus, the shifting is nothing but corresponding del of t plus b. Del of t plus b existed, del of t plus b is existed t equal to minus b. So the corresponding is equal to, this is your del of t plus b. Now the scaling a t equal to 1 and t equal to 1 by a. T equal to 1 by a to be multiplied with the each and every instant of the signal. Each and every instant of the signal, the corresponding will become minus b by a, and area of this will become 1 by a. Already we have seen. Just now we have, this is your signal del of a t plus b. This is your signal del of a t plus b. So this can be represented as the 1 by a into del of t plus b. So this can be represented as the 1 by a into del of t plus b by a. 1 by a into del of t plus b by a. So del of a t plus b is equal to 1 by a into del of t plus b by a. Right? Del of a t plus b is equal to 1 by a into del of t plus b by a. What about the del of a minus a t plus b? What about the del of minus a t plus b is equal to simply 1 by a into del of t minus b by a. 1 by a into del of b minus b by a. Since if we take this minus a out here, a into t plus b by a, the corresponding equal to 1 by a into del of t plus b by a. If we take this as the minus a outside, this minus a into t minus b by a, the corresponding is equal to 1 by mod a, that's 1 by mod of minus a, which is equal to 1 by mod of minus a, which is equal to 1 by a into del of t minus b by a. 1 by a del of t minus b by a. Spectrum point of view, if you write this graph point of view, if you write, like first of all you have to write the del of t plus b, this is equal to del of t plus b. If minus a t is equal to 1 and t equal to minus 1 by a, t equal to minus 1 by a, so the corresponding signal will become minus b into minus 1 by a. The corresponding signal is equal to b by a. Corresponding signal is equal to b by a. With strength is equal to 1 by a. Strength is equal to 1 by a. So the corresponding signal can be represented as 1 by a del of t minus b by a. Finally, we can conclude del of a t is equal to. Finally, we can conclude del of a t equal to 1 by mod a del of t. Del of a t equal to 1 by mod a del of t. 1 by mod a del of t, and del of a t plus b. If you want, we can write by taking this area outside. We can write del of a t plus b. Del of a t plus b equal to 1 by a del of t plus b by a. 1 by a del of b t plus b by a, and del of minus a t plus b can be represented as the 1 by a del of t minus b by a. 1 by a del of t minus b by a. There is no confusion at all. Take a as a common, a into t plus b by a corresponding equal to 1 by a del of t plus b by a. If you take minus a as a common, minus a into t minus b by a, the corresponding equal to simply 1 by a del of t minus b by a. 1 by a del of b minus b by a. Be careful, this is not a amplitude. This is the strength of the impulse. This is not a amplitude. Again and again saying to you, this is not a amplitude. By shifting or scaling, does not affect on the amplitude of any signal. Here it is looks like an amplitude, but it is not amplitude. This is the strength of the impulse, the area of the rectangular pulse. Now write down what is the write down the graph for the u of t plus 5. Write down the graph for the u of t plus 5 and u of t minus 3. Write down the graph for u of t plus 5 and u of t minus 3. u of t plus 5 and u of t minus 3, u of t plus 5 and u of t minus 3 and u of 3t and u of 3t, u of t plus 5 nothing but you have u of t is equal to u of t equal to 0 for t less than 0 and t equal to 1 for equal to 1 for the u of t greater than equal to 0 greater than equal to 0 for u of t plus 5, for u of t plus 5 simply t plus 5 equal to 0 and t equal to minus 5 to be added to each and every instant of the signal. So this 0 is 0 plus minus 5 equal to minus 5. So this start from the minus 5. This is your signal u of t plus 5. This is your signal u of t plus 5. Then what about the signal u of t minus 3? What about the signal for u of t minus 3? T minus 3 equal to 0, t equal to 3 to be added to each and every instant of the signal. So this will become the short from the t equal to 3. This is your signal u of t minus 3. This is your signal u of t minus 3. What about the u of 3t? What about the u of 3t? Now here this is equal to, this is the signal of this u. This is the signal u of t and u of 3t you want to write. Simply normal procedure only, not anything. 3t is equal to 1 and t equal to 1 by 3 is equal to 1 by 3. You have to multiply with each and every interval, each and every instance of this time. Here equal to 0. This is 0.5. This is 1. This is 2, 2.5 like that you have. If you multiply with 1 by 3, you have 0 and 0, 0.5 divided by 3, 0.5 divided by 3 and 1 by 3, 2 by 3 like that only you have, you will get. Like that only you will get the corresponding signal amplitude is equal to 1 only. Corresponding signal amplitude is equal to 1 only. So this signal also can be represented as a u of t only. This signal also you can be represented as a u of t only, which is equal to your u of 3t, u of 3t. So you can conclude u of kt is equal to u of kt is equal to u of t only. U of kt is equal to u of t only. U of t only. Now coming to now add these two signals u of t plus 5 plus u of t minus 3. What will happen? You will see u of t plus 5 plus u of t minus 3 up to from minus 5 to 3. Here this value is equal to 1. Here minus 5 to 3 this value is equal to 0. So up to minus 5 to 3 this value is equal to 1 only. How can you add? Means simply add the amplitude at the corresponding instances. At t equal to minus 5 this amplitude is equal to 0 and t equal to minus 5 this amplitude is equal to 0. So the corresponding value is equal to 1 up to 3, 1 up to 3, and at 3 you have this equal to 1 and 3 you have this value here. This value is equal to 1. 1 plus 1 is equal to 2. 1 plus 1 is equal to 2. So this tend up to infinity. This value is equal to, this value is equal to what? 2 values. So this is the signal u of t. Listen carefully. Conclusion is there. U of t plus 5 minus plus u of t minus 3. What will happen if u of t plus 5 minus u of t minus 3? What will happen? U of t plus 5. Simply I am going to subtracting these two signals. The corresponding signal is equal to up to minus 5 to 3. This value is equal to 1 only. From 3 onwards, here is 1 and here is also 1. 1 minus 1 is equal to 0. 1 minus 1 is equal to 0. So this is looking like a rectangle pulse only. So this is looking like a pulse only. This is equal to minus 5 to 3. This is your signal u of t plus 5 minus u of t minus 3. Listen. U of t minus 3. This value is equal to 0. This value is equal to 0 after that. Now, what is the coefficient of, what is the sum of the coefficient of this signal? Sum of the coefficient of this signal. Here the coefficient is equal to 1. Here the coefficient is equal to 1. Sum of the coefficients is equal to sum of the coefficients is equal to 1 plus 1, which is equal to 2. This is the final value of the signal. This is the final value of the signal. The signal start from minus 5 here. And what is the final value of the signal? Final value of the signal is equal to 2 only. So sum of the any signal represented in the step form, the sum of the coefficients will give you the final value of the signal. If suppose a signal is given, suppose some signal u of f of t equal to u of t minus u of t minus 3 minus u of t minus 3 plus 2 into u of t plus 3 plus 2 into u of t plus 5 plus 2 into u of t plus 5. Then what is the final value of the signal? If they ask you, final value of the signal is equal to 2 plus 1 minus 3, 2 plus 1 minus 2, 1 minus 1 plus 2, which is equal to 2. The final value of the signal is equal to, that we will see. Now listen, for this question, what is the final value of the signal? Sum of the coefficient is equal to 1 minus 1. Sum of the coefficient is equal to 1 minus 1 is equal to 0. So final value of the signal is equal to 0. Final value means the value after the final instant. The value of the final instant is equal to 3. After final instant, here the final instant is last instant equal to 3. The value after this instant is 3 equal to 0. At 3 also this value is equal to 0. This value equal to this is the final value. Listen. What is the step change? You have to concentrate on the step changes at the particular instances. Wherever the step change is there, you have to calculate what step change at the particular instances. We have first of all you have to identify at what instances the signal is going to be changed. The step changes was occurs. So here at minus 5, the initial previous step is previous amplitude is equal to 0, and at minus 5, the present amplitude is equal to 1. Present amplitude is equal to 1. Listen carefully. Like very important, right? Representing the signal in the form of steps and expression of the drawing of sketching the signals. Sketch the signals in the form from the expression of the steps. That is very important. Okay, further we have to identify the step changes at the corresponding instances. At the what instance the step change will occurs. At what instance the step change will occurs. How much step change will occur? Step change equal to change in step change is equal to change in step is equal to change in step is equal to or step change is equal to present value minus past value, present value minus previous value or past value, present value minus previous value, present value minus previous. Here some change will occur at the instant t equal to minus 5. So what is the value? Value at 5, at present value of this 5 is equal to 1, and the previous value at the instant minus 5 is equal to 0. So the step change here, at the instant minus 5 is equal to 1. Step change at minus 5 is equal to 1. So this signal can be represented as the corresponding step change into the instant u of t plus 5, like instant u of t plus 5. Then again at t equal to 3, again some changes was there, the corresponding change equal to the present change equal to 2, present step value is equal to 2, and previous value is equal to 1. So change at the instant t equal to 3 is equal to 2 minus 1, which is equal to 1, t minus 1 which is equal to 1. So we can write the corresponding change in step at the instant t equal to 3 is 1 into u of t minus 3, 1 into u of t minus 3. This is the way of representing the expression, the way of writing the expression in the form of steps from the given sketch. So this is the expression actually for the u of t plus 5 plus u of t minus 3. Now coming to this one, if the sketch is if the signal is given like this, they ask you what is the expression in the form of the step. They may ask you what is the expression in the form of the step. First of all, you have to verify at what instances the step changes was there. At what instances step change was there. Here t equal to minus 5 we have the step change, at t equal to 3 we have the step change again. So corresponding t equal to minus 5 is nothing but over t plus 5, and the corresponding instant at t equal to 3 is nothing but over u of t minus 3, What is the step change at t equal to minus 5? Here the present value is equal to 1 and previous value is equal to 0. So the change is equal to 1 minus 0, which is equal to 1. So we have to write this quotient is equal to 1 into u of t plus 5. And again here the present value of this is equal to 0, the previous value of this is equal to 1, the change in step is equal to present minus previous 0 minus 1, which is equal to 0. Present minus previous 0 minus 1 is equal to minus 1. So you have to write here is equal to plus minus 1 minus 1 as the coefficient, and the final expression for the signal is equal to u of t plus 5 minus u of t minus 5 minus u of t minus 5. Simply you can write like this. You have to identify the instances wherever the change was occurs, the corresponding instant you have to write down like this. The corresponding coefficient can be calculated as the change in the step, corresponding change in step change, which is equal to present step minus the previous value, present value minus the previous value. Now the expression is given as like this: u of t equal f of t equal to u of t minus 3 plus 2 into u of t plus 5. They are asking to represent the signal. Similarly, here what are the instances are there here? First of all, what are the instances are there here? Here the corresponding instances are t equal to t plus 5 is nothing but t equal to minus 5, and at t equal to 0, and the corresponding u of t minus 3 is nothing but the instant at t equal to 3, these are the corresponding instances. Now the coefficient of this u of t plus 5 equal to 2. U of t plus 5 is equal to 2. That is nothing but the change in step is equal to 2, which is equal to present value you have to calculate minus previous value you have to consider always 0, minus 0. So present value is equal to 2. So at this minus 5, the present step should be 2 up to what value? Up to the next instant t equal to 0. Up to the next instant t equal to 0. Now at t equal to 0, what is the step change here? T equal to 0. Now you are at t equal to 0. What is the step change here? 1. So 1 is equal to present minus previous value. Previous value is equal to how much? 2. Previous value is equal to how much? 2. So the corresponding present value is equal to 2 plus 1, which is equal to 3. Corresponding present value is equal to 2 plus 1, so which is equal to 3. So at this value the corresponding amplitude is equal to 3. Corresponding amplitude is equal to 3. Now coming to instant t equal to t equal to 3, up to the constant 3 up to what instant t equal to 3, up to the next instant t equal to 3. At t equal to 3, for t equal to 3, what is the step change? What is step change equal to minus 1? This minus 1 is equal to present value you have to calculate minus previous value is equal to how much? Minus 3. Minus previous value is equal to how much? Minus 3. From this you can write t is equal to minus 1 plus 3 which is equal to 2. So at this t value again this value is equal to 2, and after that is constant at t value. There is no next change at this next instance, there is no change they have given. So that after 3 this value is constant at 2 only, after this value is constant at 2 only. Right, again listen carefully. Again I am giving to you the corresponding change is equal to, here the step change is equal to 2, here where we are at minus 1. Now coming to this one, present t equal to minus 5, t equal to minus 5, the corresponding instances are t equal to minus 5, the corresponding change step is equal to 2. So corresponding to equal to present minus previous equal to 0, present is equal to 2 values. So at minus 5 you have to consider the corresponding value is equal to 2 up to what, up to the next instant t equal to 0. At t equal to 0 we have change step is equal to 1. This 1 is equal to simply present minus previous. What is the present value? You have to calculate. Previous is equal to 2 here. Just before 0. Before 0 minus equal to 2 value. So the corresponding present value is equal to 3. Now the 3 up to what? Up to the next instant. Next instant at t equal to 3. At t equal to 3 corresponding change step is equal to minus 1. So minus 1 is equal to present minus previous. Previous is equal to what? Previous is equal to 3. Right? From this the present value is equal to 2. So final value of the signal is equal to. So final value is equal to 2 only. So what is the summation of all the coefficients of the signal? Summation of all these coefficients of the signal is equal to 1 minus 1 plus 2. 1 minus 1 plus 2. This value is equal to 1 minus 1 cancel. This value is equal to 2. This is the final value, and this is the final value they have given. Suppose if the signal is represented like this. Write down the expression in the form of the step. The signal representation is given as like this. Suppose here is equal to like this. 1, 2, 3, 4. 1, 2, 3 corresponding amplitudes are 1, 2, 3 corresponding amplitudes are 1, 2, 3. This is your f of t. They ask you to represent the signal f of t in the form of steps. First of all, what is the at what instances the step change was occurs. The step change occurs, we have to identify. At the instant t equal to 1, this changes to 0 to 1. T equal changes to 0 to 1. At t equal to 2 also some change was there. At t equal to 3 also some change was there. Suppose if we consider instead of 4, if we take this as a 5, the corresponding is equal to 4. This corresponding is equal to 4. I am considering. Okay, here at t equal to 1 you have equal to, so u of t minus 1, and the corresponding is u of t minus 2. Corresponding is equal to u of t minus 3, and the corresponding is u of t minus 4 and u of t minus 5. You have to calculate the corresponding coefficients. The coefficient is equal to simply the change step. At t equal to 1, what is the change step? Present is equal to 1 and previous is equal to 0. So 1 minus 0. And what about this t minus 2? Is equal to simply 2 minus 1 here, because at t equal to 2 the present value is equal to 2 and the previous value is equal to 1. So 2 minus 1. Coming to t minus 3. What about this one? Present value is equal to 3. And previous value is equal to 2, so 3 minus 2. What about this t minus 4? T equal to 4. Present value is equal to 3 only. Previous value is equal to 3 only. So the corresponding change step is equal to 3 minus 3. Corresponding is equal to 3 minus 3 plus at 5 the present value is equal to 0 and previous value is equal to 3, so is equal to 0 minus 3. Finally you can represent this as the u of t minus 1 plus u of t minus 2 plus u of t minus 3. U of t minus 3 plus 0 into something is equal to 0 minus 3 into u of t minus 5 minus 3 into u of t minus, no need to write this one. So if there is no, if so the instances what you have to consider are the only the change, wherever the change occurs those instances only you need to consider. At t equal to 4 no need to consider because there was no step change at t equal to 4. Now what about the summation of all these coefficients of the signal is equal to simply 1 plus 1 minus 3 which is equal to 0. This is the final value. This is the final value. Now represent the signal r of t minus 1. Represent the signal r of t minus 1, r of t plus 3 and r of 2t. R is nothing but your ramp signal. R of t is equal to the signal ramp signal is equal to simply t into u of t. This exists only for the positive values of time, and after that is of the format y equal to mx only linearly increases like this. Is the ramp of the signal. The corresponding value 1 here is equal to 1, here equal to 2. Corresponding amplitude is equal to 2. Now they ask you to write the r of t minus 1. R of t minus 1 is nothing but simply t minus 1 is equal to 0 and t equal to 1. So this starts from t equal to 1. So 1 0 minus 1 t t minus 1, right? T minus 1 means it starts from t equal to 1. So this is from like this is from like 1, this is 2, this is 3, this is 4, like that. 1, 2, 3, 4. Now, if this is the corresponding r of t minus 1, not a new thing. Okay, r of t plus 3 nothing but t plus 3 equal to 0 and t equal to minus 3. So it should start from t equal to minus 3. So it start from t equal to minus 3, minus 2, minus 1, like that, whatever they have given, right, like that. Now, what is the amplitude of this at t equal to 0? What is the amplitude of this at t equal to 0? T equal to 0 is nothing but the instant, previous instant was t equal to 3. Previous instant was t equal to 3, right? 3 minus 3 equal to 0. 3 minus 3 equal to 0. In the previous signal at t equal to 3, the corresponding value is equal to 3. So at t equal to 3, at t equal to 0, in this r of t plus 3, in this r of t plus 3, the corresponding value is equal to amplitude is equal to 3. That also may ask you, what in the expression of r of t plus 3, what is the amplitude at the particular instant? Suppose they ask you what is the amplitude at the instant t equal to 2. What is the amplitude at the instant t equal to 2? Then t equal to 2 is nothing but the new is 2, the previous one is maybe at t equal to 5. Original instant was t equal to 5, the amplitude at t equal to 5 is equal to, amplitude at t equal to 5 is your 5. So at the t equal to 2 instant, the corresponding amplitude is equal to 5. The corresponding amplitude is equal to 5. Like that we can calculate, not anything, not a difficult thing here. Now what is the r of 2t? R of 2t. Here we have r of t is equal to t into u of t. Simply r of 2t is equal to 2t into u of 2t. 2t into u of 2t, as we know u of kt equal to u of t only. So this can be represented as 2t into u of t. So this is equal to 2 into r of t. 2 into r of t. So you can conclude r of kt is equal to k into r of t. You can conclude r of kt is equal to k into r of t. That is nothing but the time scaling leads to what? Here the time scaling leads to amplitude scaling. Time scaling leads to amplitude scaling. In the ramp signal, which are the following signal? Time scaling leads to the time scaling leads to the amplitude scaling. Step signal, ramp signal, impulse signal, and none of the above. None of the above. Then the signal is equal to r of kt. In general, till now we learned that r of kt. Till now we learned scaling may not affect the amplitude of the signal. Amplitude of the signal here. The scaling r of kt affects the amplitude of the signal because here the amplitude depends on the t value, depends on the instance of the time instance of the signal f of t. As the time instants are going to be definitely shifting or scaling, time instants may be changes. So the time instants are changing, so the corresponding amplitude also may changes. Here this r of kt, the time instants are changing as amplitude depends on the value of the time instance. So the corresponding value also changes. The corresponding value also changes. Now r of kt is equal to k into r of t. Now k into r of t, nothing but time scaling leads to the amplitude scaling. Now if you represent the signal in the form of ramp, then how can you calculate? Here we are concentrated in step signal point of view, we have concentrated the change in step at the instances. In the ramp point of view, we have to concentrate the change in slope at the signal, because r of t is equal to what you have given, r of t equal to t into u of t. T into u of t, if you consider t, this is of the format y equal to mx, right? This is the format y equal to mx. The slope of the signal is equal to 1. Slope of the signal is equal to 1. Throughout the signal, the slope is constant. At any value, if you consider the slope is constant, if the signal is equal to like this, the slope of the signal is equal to constant, which is equal to 1. In step signal, u of t is equal to t into u of t is equal to 1. Here the amplitude is constant. So we have considered wherever the amplitude changes, the corresponding instances we have taken. From that we have calculated the corresponding step change at that instant. Here what is the constant value? Here the constant value is equal to slope. So we are concentrating on the change in slope at the particular instances. Wherever the slope change occurs, the corresponding instance we have to consider. And the change in slope to be considered as the amplitude of that one, as we have done in the step signal representation. Now represent the signal in the form of represent the signal -1 1 1 in the form of ramp signal. This is the signal f of t they have given. They are asking to represent the signal in the form of the ramp. So here the previous slope is equal to 0. What is the slope of this one? Is equal to 1 minus 0 divided by 0 minus of minus, which is equal to 1. Slope of this one is equal to 1. The slope of this one is equal to minus 1. So the signal at present the signal having the zero slope. The zero slope is going to be changes to 1 at the instant t equal to minus 1. So you have to consider that t equal to minus 1 instant corresponding is equal to r of t plus 1. Is r of t plus 1 corresponding is equal to r of t plus 1. Now again here the slope is equal to 1. The slope is going to be changes to minus 1 at the instant t equal to 0. So you have to consider the corresponding instant as the r of t. Corresponding instant as the r of t. No problem. We will calculate the coefficients. First of all, I am writing the instances wherever the slope changes was occurs. Now here the slope is equal to minus 1 up to t is equal to 1. After 1, the slope is going changes to 0. Going to changes to 0. So this instant also you have to consider which is equal to r of t minus 1. This instant also you have to consider which is equal to r of t minus 1. R of t minus 1. Now what are the coefficients? Here the coefficient is equal to simply change in slope at the instant. Change in slope at the instant. Okay, here what is the change in slope? Here the change in slope is equal to 1 minus 0, which is equal to 1. So we have to write here equal to 1. What is the change in slope here? Change in slope here is equal to minus 1, which is equal to minus 2. So we have to write here is equal to minus 2. What is the change in slope here? Slope here equal to 0 minus 1, which is equal to 1. So the corresponding is equal to 1. So finally we can represent this equal to r of t plus 1 minus 2 into r of t plus r of t minus 1. As the signal is represented in the step format, Sum of their coefficient is equal to sum of their coefficients gives you the final value of the signal. If the signal is represented in the ramp format, the sum of their coefficients will gives you the final slope of the signal. Here sum of their coefficient is equal to 1 minus 2 plus 1 is equal to 0, which is your final slope. Final slope of the signal is equal to 0 only. So sum of the coefficients will give you the final slope of the signal. Here the final slope is equal to 0. Only. Take input a note. Sum of the coefficients will give you the final slope of the signal. They will give you some signal, some random signal like this. R of t plus 1 minus 2 into r of t plus 3 into r of t minus 5 plus 5 into r of t minus 10. What is the final slope of the signal? They may ask you. The corresponding final slope is equal to simply 1 minus 2 plus 3 plus 5, which is equal to 1 minus 3 plus 3. 9 minus 7, which is equal to 7. Like that you can directly write. Down. Then what represent the signal f1 of t and f2 of t in the form of ramp signal. For f1 of t, first step is that you have to identify the instances for the slope change. Wherever at what instances the slope change occurs. Here equal to 0, here slope is equal to 0. This suddenly changes to slope is equal to 1. First you have to calculate slope here is equal to 1 minus 0 by 1 minus 0, which is equal to 1, and here the slope is equal to 0. So you have to consider the instant r of t. Now again here at t equal to 1, this slope is equal to 1. This slope is suddenly changes to 0. So that instant also you have to consider. Observe in this signal here the value at t equal to 1, this value is equal to 1. This 1 is suddenly drops to 0. That is nothing but some step change also was there, some hidden step change also was there. So the corresponding step change also you have to consider. Getting here the change equal to 0, suddenly is not changing the amplitude. Amplitude is going to be linearly increases. Okay, slowly increases. And here this amplitude is equal to 1. This suddenly drops to 0. Is nothing but some sudden change was there. Nothing but some step change was there at t equal to 1 instant. So you have to consider that step change also is equal to u of t minus 1, which is equal to very important, u of t minus 1. Now corresponding coefficient you have to calculate. Here the slope change equal to 1 minus 0, which is equal to 1 only. Here the corresponding slope change equal to 0 minus 1, which is equal to minus 1. And the corresponding step change here you have to consider. The present is equal to 0, previous is equal to 1, So this value will become 0 minus 1 is equal to. So the final expression can be represented as the r of t minus 1 minus u of t minus 1. This is the expression for this f1 of t. If you convert this total integral in the form of the steps, we can write this equal to t into u of t minus t minus 1 into u of t minus 1 minus u of t minus 1. By taking this u of t minus 1 as common, u of t into u of t minus t into u of t minus 1 minus t into u of t minus 1 minus minus plus u of t minus 1 minus u of t minus 1. So this can be represented as the t into u of t minus t into u of t minus 1, t into u of t minus t into u of t minus 1 minus u of t minus 1. This is the expression for this one. Now coming to this f2 of t. What about this f2 of t? Here the present slope is equal to 0. The slope is going to be changes it changes to 0 to 1, and after that at t equal to 1 instant this is changes to 0. At t equal to 1 instant this again changes to 0. I am retrying here this f2 of t. This f2 of t equal to like this. The signal is like this. Here equal to 0, it changes to 1, and after that it changes to 0, changes to 0. So corresponding instances are r of t, corresponding instances are r of t and r of t minus 1 and r of t minus 1. At r of t, the corresponding change will be equal to 1 minus 0 is equal to 1, and at t equal to 1 instant, the corresponding change equal to 0 minus is equal to minus 1. So this can be represented as the r of t minus r of t minus 1. This is the representation of this signal. There is no sudden change at t equal to 1, so we are not considering the u of t minus 1. So we are not considering the u of t minus 1. Now u of t minus 1. Now what next? Can you draw the signal from? Can you draw this pulse from this expression? T into u of t nothing but this one only. T into u of t nothing but this one only. The corresponding value at t equal to 1, this value is equal to 1, and t equal to 2, this value is equal to 2. And what about this t into u of t minus 1? T into u of t minus 1 is nothing but t equal to this one only, and u of t minus 1 is equal to this one only. U of t minus 1 is equal to, it starts from 1, right? It starts from 1. This is our corresponding signal. Here this could be equal to 1. This upon multiplying these two signals, the corresponding value is equal to, upon multiplying these two signals, the corresponding value is equal to, at t equal to 1, this value is appear. This is the corresponding signal. If you subtract these two signals, what you will get? Up to 0 to 1 nothing is there, so the signal is equal to up to 0 to 1 like this only. At t equal to 1, this value is equal to 1 minus 1 0. At t equal to 2, this value is equal to 2, and this value is equal to 2. 2 minus 2 is 0, 2 minus 2 is 0, 3 minus 3 is 0, 4 minus 4 is 0. The corresponding signal is equal to this one. This is our original pulse signal they have given. Now what about this one? Can you draw from this r of t minus 1? R of t minus 1 is nothing but simply u of t minus 1 into r of t equal to your signal like this only. This is your r of t, and r of t minus 1 is equal to like this one, t equal to 1 from 1 onwards. So here this value is equal to 1, up to this value equal to 0, up to this value is equal to same only, because there nothing is there here. By subtracting these two, here this value is equal to 1, the corresponding value in this signal is equal to 0, so 1 minus 0 is equal to 1, 1 minus 0 is equal to 1. Here this value is equal to, here at the instant t equal to 2, this value is 1. At instant t equal to 2, the corresponding value is 2. So 2 minus 1 is equal to 1. At 3, this value is equal to 2, and the corresponding is equal to 3. 3 minus 2 is equal to 1. So this is constant at 1 only. This is only your shape. This is the way of writing expression from the given signal. We have to concentrate about the slope changes and the step changes also. Okay, if any signal they have given, and they ask you to represent the given signal in the form of the step and ramp. At that situation, you have to concentrate on both slope changes and the step changes. Now write down the question, this one, and represent this in the form of the step and ramp. Represent the following signal in the form of the step and ramp. The corresponding signal is equal to, is given by like this. This is the signal they have given. The instants are 1, this is 2, this is 3, and corresponding amplitude here is equal to 3, and the corresponding amplitude here is equal to 1.5, and the corresponding amplitude here is equal to minus 1.5. Represent the signal in the form of step and ramp. In the form of step and ramp. Okay, first of all we have to observe what are the corresponding step changes and the slope changes, and those slope changes, step changes at what instances. Those instances we have to write separately. Try to do. Try to do. Not Simple only, not a new thing or not a difficult thing. Nothing is there. Simple questions. When we have to concentrate on the instances where the slope change occurs and where the step change occurs. Though both you have to consider. For this signal, for these two you have to draw the corresponding signals. Corresponding signals. You have to sketch the corresponding signals. Here. What is the first one? You have to calculate the corresponding slopes. What is the corresponding slopes here? What is the slope of this one? Slope of this one is equal to simply 3 minus 0 upon 0 minus 1, right? Is equal to minus 3. Slope is equal to simply minus 3. The corresponding slope here is equal to minus 3. Always write like this. Minus 3 always write like this. What is the slope of this one? Slope of this one is equal to simply 1.5 minus of minus 1.5 divided by 1 minus 3, right? 1 minus 3, so this value is equal to 3 by minus 2, which is equal to minus 1.5. The corresponding slope here is equal to minus 1.5. Now next, whatever the slope of this one, after this slope is equal to 0. Is there any sudden changes what happened? Yes, exactly. Here is equal to 0. Here this value t equal to 0. Before 0 this value is equal to 0. Suddenly it changes to the value 3. So at t equal to 0, you are having the sudden change. Step change also is there. So you have to consider u of t. Now, is there any slope change at t equal to 0? Definitely. Here slope is equal to 0. At t equal to 0, suddenly slope is changes to minus 3. So you have to consider the corresponding r of t also. We have to consider the corresponding r of t also. Now coming to t equal to 1. At t equal to 1, again at t equal to 1 slowly decreases to 0, suddenly changes to 1.5. So you are having the step change at t equal to 1 also. And what about the slope? Up to this slope is equal to minus 3, the slope changes to minus 1.5. So you have to consider the slope corresponding ramp also, r of t minus 1. Now coming to t equal to 2. At t equal to 2, is there any step change? So it is slowly decreasing. There is no sudden change at t equal to 2. So you are not supposed to consider the corresponding step. And is there any slope change at t equal to 2? Here slope is equal to minus 1.5. Here also minus 1.5. Change is equal to 0 only. There is no slope change at t equal to 2. So you no need to consider the instant t equal to 2. Now we are at t equal to 3. Here this value equal to minus 1.5 suddenly drops to 0. So you have to consider the corresponding step change at t equal to minus 3. And is there any slope change? Yes. Here is slope change equal to minus 1.5. It suddenly changes to 0. So the some slope change was there at t equal to 3 instant. So you have to consider r of t minus 3. You have to consider r of t minus 3. Now I am going to writing the corresponding amplitudes. At t equal to 0, the corresponding change equal to 3 minus 0, which is equal to 3. Explanation point of view taking some time. Directly you can write in 5 seconds. You can write the answer. Okay, 3 into u of t, and what about this r of t? Change slope is equal to minus 3 minus 0, so this is equal to minus 3 into r of t. And what about this u of t minus 1? At u of t minus 1, this value changes to 1.5 minus 0, so this is equal to 1.5. And what about this slope coefficient of this r of t minus 1? Here the present slope is equal to minus 1.5. The corresponding change slope is equal to minus 1.5 minus of minus 3. Minus 1.5 plus 3, which is equal to 1.5, Now, so the corresponding coefficient is equal to 1.5. What about this u of t minus 3? U of t minus t equal to 3. You have the present is equal to 0. Previous equal to minus 1.5. 0 minus of minus 1.5, which is equal to 1.5. This one plus 1.5. And what about this slope change? Here slope is equal to 0 and here slope is equal to minus 0.5. Change equal to 0 minus of minus 1.5. This slope is equal to 0 minus of minus 1.5, which is equal to 1.5. So the corresponding is equal to 1.5. This is the expression for this signal. 3 into u of t minus 3 into r of t. Plus 1.5 into u of t minus 1 plus 1.5 into r of t minus 1 plus 1.5 into u of t minus 3 plus 1.5 into r of t minus 3. Like this, we have to write the expression from the given sketch. Now, in the reverse process here, they are asking to sketch the corresponding signal. The first one is very easiest only. If you represent this in the ramp point of view, is equal to r of t minus 1. Right, 2 into r of t minus 1 minus 2 into r of t minus 2 plus 2 into r of t minus 3. So the instances t equal to 1, t equal to 2 and t equal to 3 you need to consider. You need to consider at t equal to 1, at t equal to 1, the corresponding change in slope is equal to 2, corresponding change in slope is equal to 2, so 2 equal to present minus previous equal to 0, so present slope here is equal to 2, present slope here is equal to 2, up to what value, up to what value, up to the value 2, up to the value, up to the next instant 2. Here now at the instant t equal to 2, we are having the change in slope is equal to minus 2, change in slope equal to minus 2, is equal to present minus previous, previous is equal to 2, so the present slope is equal to 0. So here this value is equal to 0. Is there any sudden change in the step? Is there any sudden step change? No, nothing is there. There is no sudden step change. So you have to consider the constant value up to what value? Up to the next instant t equal to 3. Up to the next instant t equal to 3. At t equal to 3, what is the change again? Change again 2. So 2 is equal to the present p we have to calculate minus previous is equal to 0. So p is equal to present we have to calculate. Right. Step change equal to 2 and present you have to, so present slope is equal to 2 from this onward, present slope is equal to 2. So the corresponding expression can be represented as like this. Corresponding representation of the signal is like this. This is your signal f1 of t or f of t whatever. Corresponding speech of this signal. Like this you have to calculate in the reverse way. Now coming to this one, coming to this one. Here what is the difference of this question and this question? Here directly they have t minus 1 into u of t minus 1. Directly you can write r of t minus 1. Here they have given t plus 1 into u of t minus 1. T plus 1 into u of t minus 1. For this how can you represent this one? T plus 1, but we want for r of t minus 1 we want t minus 1 into u of t minus 1. So simply add plus 1 and minus 1, add plus 1 and minus 1. So this can be represented like this. We have to separate like this. We have to represent like this, equal to minus t into u of t and u of t minus 2 minus u of t minus 2 minus u of t minus 2. Now from this you can write here as the t minus 1 into u of t minus 1 or t minus 1 into u of t minus 1 plus 2 into u of t minus 1 plus 2 into u of t minus 1 minus t into u of t minus t into u of t minus u of t minus 2 minus u of t minus 2. This is the expression. This is the modification of this expression. Now, what are the corresponding instances they have given? What are the corresponding instances they have given? This can be represented directly r of t minus 1 plus 2 into u of t minus 1 minus r of t minus u of t minus 2 minus u of t minus 2. So you are at r of t. R of t is nothing but t equal to 0. At t equal to 0, at t equal to 1 they have given, and at the instant t equal to 2 and the instant t equal to 2. At t equal to 0, what is the slope change? What is the slope change equal to? Minus 1. So minus 1 is equal to present minus previous equal to 0. Always we consider the corresponding present slope change equal to minus 1. Present slope is equal to minus 1. Slope equal to minus 1 up to what value? Up to the next instant 1. Up to the next instance 1. So at the instant t equal to 1, you have sudden change also is there and sudden slope change also is there. Sudden slope change also is there. First we are considering the sudden step change. Here what is the value? What is the value here? At t equal to 1, the corresponding is equal to minus 1. Since slope is equal to 1 only. Since slope is equal to minus 1. Slope is equal to minus 1 only. Minus 1 equal to y2 minus 1 by x2 minus x1. From this you can calculate this value is equal to minus 1. Now the corresponding step change at t equal to 1 is equal to 2. Corresponding step change 2 is equal to present minus previous value. Previous value is equal to what value? Previous step value here is equal to minus 1. So this value is equal to present value is equal to 3. Present value is equal to 3. So at t equal to 1 suddenly raises to the step 2 equal to 3. Suddenly raises to 3 or not? 2 is equal to p plus 1. P is equal to 1. P is equal to 1. So the presently at t equal to 1, this changes to the corresponding amplitude 1. Corresponding amplitude 1. Now what about the slope? What about the slope change? Slope change equal to 1. Slope change equal to 1. So 1 is equal to present slope is equal to how much? Present slope equal to how much? You have to calculate. P minus whatever the previous slope. Previous slope here is equal to minus 1. Minus half minus 1. So this value 1 is equal to p plus 1. P is equal to 0. Present slope at this equal to 0. Up to what instance? Up to next instance t equal to 2. At t equal to 2 we are having any slope? You are having any slope change? No. We are having only step change u of t minus 2. What is the corresponding step change they have given? They have given is equal to minus 1. Corresponding step change equal to minus 1. This minus 1 is equal to present minus previous. That is p minus previous equal to how much value? 1. P minus 1. So this value is equal to what you will get is equal to simply p minus 1 or not minus 1. p minus 1. So this value is equal to p is equal to 0. So corresponding corresponding step value at this 2 is going to be 0. This is the corresponding expression for the corresponding sketch of this signal f of t. This signal f of t. Like this you have to calculate. Just simple identification of the step changes and slope changes at the corresponding time instances. Nothing is there at the corresponding time instances. So write down those time instances separately, and the corresponding expression you have to write. Don't forget to consider the sudden changes. Consider the sudden changes like this. Okay, the signal is like looking like a ramp signals only. You may forget to write to consider the corresponding step changes. Those who are not supposed to forget, those you have to consider. Now the given signal f of t equal to like this, just from 1 to 2, and amplitude is equal to 1, and corresponding g of t of the rectangular pulse in 1 to 2 represent. The question is that for all these questions represent g of t in terms of f of t. G of t to be represented in the form of m of t. The given signal f of t equal to like that. If you develop a signal like this, if you develop one signal like this in 1 to 2, if the corresponding amplitude equal to 1, by adding these two signals, the corresponding signal will be, here the amplitude is equal to 0. The amplitude is equal to 0, corresponding amplitude is equal to 1. If you consider middle of the signal, the corresponding amplitude is equal to 0.5. Here also the corresponding amplitude is equal to 0.5. Here also the corresponding amplitude is equal to 0.5, and the corresponding time is equal to 1.5. The corresponding time is equal to 1.5. By adding these two, you have one only. Okay. Suppose if you consider the value here to 2, that is 1.9. If suppose 1.9, here the value is equal to 0.2. The corresponding value 1.9 here is equal to 0.8. Corresponding value here is equal to 0.8. 0.2 plus 0.8 is equal to 1. So by adding these two signals, we have a rectangular pulse 1, 2. This is your required g of t. This is your required g of t. Our intention is g of t can be represented as the f of t plus this signal. How can you represent this signal in the form of f of t? In the form of f of t. This is the question we have. Now this signal, how can you represent this signal in the form of f of t? So I am writing this as the f of minus t plus 3. So first I am writing this f of t plus 3. F of t plus 3 equal to t plus 3 equal to 0 and t equal to minus 3. The corresponding signal will become minus 3 plus 1 that equal to minus 2, and minus 3 plus 2 that equal to minus 1. The corresponding signal is equal to this one. If you write f of minus t plus 3, the corresponding signal is equal to 2 will become minus 2 will become 2, and minus 1 will become 1. This is your signal. This is our required signal f of minus t plus 3. How can you write directly? That is simply, this is the form simply f of, by adding these two limits, 2 plus 1 is equal to 3. By adding these two, 2 plus 1 is equal to 3. That is f of t plus 3, and simply you have to write f of minus t plus 3. Suppose if the signal is given like this, the signal is given like this, sum from minus 1 to 1, then if you want to develop a signal of this like this, then simply you have to write this f of t equal to like this only. F of t equal to 1 minus 1 is equal to 0 plus minus t. 0 minus 1 equal to 0 minus t. This is directly f of minus t only. F of minus t equal to 1, t equal to minus 1. If you multiply this minus 1 with instance of this time, minus 1 into minus 1 will become 1, and minus 1 into 1 will become minus 1. Minus 1 into 1 will become minus 1. This is the corresponding signal of this one. This is equal to, simply we can write minus 1 plus 1 is equal to 0, and minus t. Like that only I have written. This 1 plus 2 is equal to 3. The corresponding signal is directly f of minus t. If suppose they given a signal like this, if they given a signal like this, it is from 1 to 2. This is from 1 to 2. And if they ask you to write the f of minus t plus 3, simply you can write directly. This is equal to, this is your 2 and this is your 1. Directly you can write like this. Simply by reversing the signal only, like that. If you are still having the doubt, no need to write anything. Simply remember this. Simply observe this one. This is from minus 1 to 1. Corresponding f of minus t is equal to your signal minus 1 to 1. Simply the reverses, minus 1 part will become 1 and 1 part will become minus 1. This can be represented as the f of minus t plus summation of these two instances, 1 minus 1 0. So here also we can write the sawtooth pulse. The sawtooth pulse can be represented here also. The sawtooth pulse can be represented here also like this. 1 plus 2 is equal to 3. F of t plus 3, and by placing minus t, you will get the sawtooth pulse in like this. By adding these two sawtooth pulses, you will get the corresponding rectangular pulse between 1 and 2. Rectangular pulse between 1 and 2 is very, very important concept. It is in the Fourier transform also they will give you the signal f of t equal to like this, signal f of t equal to like this. Then what is the Fourier transform of the signal g of t? Then directly you can write by add d of t equal to f of t plus f of minus t plus 3, f of minus t plus 3, simply summation of these limits only. Again this concept will appear in the battery communication system of the battery filter also. The impulse response of the filter h of t is equal to x of t minus t, x of capital T minus t. At that situation also this is simply x of minus t plus t. This t is the summation of the limits, width of the given signal x of t, that is nothing but summation of the limit, summation of the limits only. At that situation also we will repeat, we will again discuss about this concept. So remember this concept as the summation of this lower limit is equal to 3, and simply we have to place in place of t minus t, then you will get the pulse. The pulse of like this. By adding these two, you have your rectangular pulse. So this g of t can be represented as f of t plus f of minus t plus 3. In examination also directly you can write without doing any calculation. The summation of this lower limit and the upper limit. Coming to second question, given f of t is equal to like this, then they are asking express the g of t in terms of f of t. Very, very important concept, please. Expression of the one signal in the form of the given signal. Here f of t equal to like this. So g of t they have given as I am taking as the g of t is equal to g of t is looking like a signal with adding of some DC signal, right? With adding of some DC signal they have given. Here this value is equal to 2. Here this value is equal to 2. I am simply subtract. I am writing the signal as the 2 minus g of t. 2 minus g of t can be represented as the this is simply like this only. 2 minus g of t I am writing. Right, 2 minus g of t I am writing. This simply like this only. The corresponding signal is equal to here is equal minus 1 2. Here this value is equal to 2. Here this value is equal to 2. Now we are supposed to develop a signal like this, or otherwise directly write down the signal f of t is equal to simple observation only, nothing is there here. This is your 4, this is your minus 2, amplitude is equal to 2 here, amplitude is equal to 2 here, and corresponding amplitude here is equal to minus 1, here is equal to minus 1. First of all observe here. This is a triangular shape, I think. Sorry. This is a triangular shape. Here this is looking like a sawtooth pulse, and this is looking like a triangular shape. This is a triangular shape. Okay, in g of t you are having the triangular shape at this place, and the sawtooth shape in this part. So first of all you need to remove this signal, that is minus f of t, amplitude scaling minus f of t. By doing this minus f of t, this will become the amplitude will become 2 will become minus, this 2 will become minus 2, this corresponding amplitude will become minus 2, and this value will become 1, and this value corresponding amplitude is equal to minus 2. Here the value of 4. This is the signal like this. Now even though in this g of t this triangular shape to be in the left hand side, here the triangular shape in the right hand side, so we have to take this triangular shape into the left hand side. The corresponding I am writing as the minus f of minus t. If I write minus f of minus t, the signal is from 4 to 2. This 4 will become minus 4, this 4 will become minus 4, and the minus 2 will become your 2 only. So 2 only, and amplitude and everything is same only. So the shape will become like this. The corresponding value in the f of minus t. Now this width is equal to from minus 1 to 2. Here the width is equal to 2 minus of minus 1, 3. Here width is equal to 2 minus of minus 4, width is equal to 6. So you have to compress the signal. Is nothing but simply you have to make this width 6 to the 3. We have to divide this 6 divided by 2. We have to do 6 divided by 2. The corresponding signal is equal to 2. So we have to write this f of minus 2t. Then the width will become, here the width is equal to 6. Then the width will become 2. So simply the signal